In physics, there are a set of three quantities that are closely related via calculus. The first quantity is the position of a particle along a straight line. We usually denote this quantity by x. The instantaneous rate of change of position is known as the instantaneous velocity of the particle. We usually denote velocity by v. And since an instantaneous rate of change is the derivative, the velocity of a particle is the derivative of the position. Similarly, the position function is an antiderivative of the velocity function. The instantaneous rate of change of velocity is known as the acceleration, which is called a. Acceleration is usually the derivative of velocity, and thus it is the second derivative of position. We usually think of position, velocity, and acceleration as functions of times. The position function is x of t, the velocity function is v of t, and the acceleration function is a of t. If we know one of these three functions, we can find the other two either using derivatives or antiderivatives. So in example 1 here, we have the position function of a particle moving along a straight line is x of t equals 3 sine pi t. We want to find the velocity and the acceleration functions. So the velocity function, v of t, is going to be the derivative of the position function. So it's going to be x prime of t. So if we do the derivative of this, the 3 in front is going to stay. The derivative of sine is going to be cosine, and since it's not just a t inside, it's a pi t inside, we have to multiply by the derivative of the inside function using the chain rule, which gives you 3 pi cos pi t. So now if we want to find the acceleration function, we've got to take in turn the derivative of the velocity function. When we do that, the 3 pi is a constant, it's going to stay in front, the derivative of cosine is negative sine, and then we have to multiply by the derivative of the inside function times pi t prime, which is just pi, so we get negative 3 pi squared sine of pi t. So again, using differentiation, we can find the velocity and acceleration functions from the position function. In example 2, we have an acceleration function of a projectile launched upward. It's given by a of t equals negative 10. The projectile is launched from the ground with an initial velocity of 2. The question is, what's its height above the ground as a function of time? So the idea is here we're going to do anti-differentiation. We've got the acceleration, which is the second derivative, and we want to find the height, which is the original function. Well, firstly we're going to find the velocity function. v of t, we're going to do the antiderivative of negative 10, which gives you negative 10t plus c. Now we want to find c. Well, there's going to be some information given that will allow us to find c. The initial velocity is 2, which means v of 0 is 2. So let's plug in 0 for t. v of 0 here is 2 here. Plug in 0 for t, I get negative 10 times 0 plus c, so c equals 2. So my velocity function is v of t equals negative 10t plus 2. Now if I want to find my position function, my height, I've got to do the antiderivative of this. So my position function x of t is going to be, the antiderivative of negative 10t is going to be negative 10 times 1/2 t squared. The antiderivative of 2 is 2t, and then I'm going to have another constant d. This simplifies to negative 5t squared plus 2t plus d. Now, this is launched from the ground, which means the height at time 0 is going to be 0. So this is saying that x of 0 is 0. I'm going to plug in 0 for t. I get x of 0 on the left, which is 0. On the right, I get negative 5 times 0 squared plus 2 times 0 plus d. This basically tells me that d equals 0. So my height function is x of t equals negative 5t squared plus 2t, and the d is 0, so we can forget about it.